on page 10 of our notes, which I think is the very last problem in the 2.7 section. So our 2.7 homework will be due next Monday, so a week from today. Feel free to send that to me at any time. I am slowly but surely making my way through your papers. I'm responding as I get to them, so it takes a while, but I hope to get those wrapped up in the next week or so also, hopefully. All right, but here we go. We're in our notes, page 10, number 10. It says, consider all rectangles with an area of 182 square feet. So I hope you're thinking about drawing a rectangle. And all we know about this rectangle is that its area is 182 square feet. They tell us to let x be the length of one side. So I'll go ahead and mark that x. Does anybody have an idea what we might call the other side?
182 minus x?
Close. It wouldn't be 182 minus x. It would be 182 divided by x. Why is it 182 divided by x?
Because the number x is part of what makes 182.
Yeah.
So you're going to take that part off.
So, in other words, think about it for a second. If you had a rectangle and you knew that the area was 42 and you knew this was 6, how would you find this dimension? Since length times width is the area, wouldn't this be 42 divided by 6 or 7? Area is length times width. So if we know the area, we're going to divide it by the length in order to get the width. All right, now what am I doing here? I got my picture drawn. Let's see. Express the perimeter as a function of x. All right, how do we find perimeter? How do we find perimeter of anything?
Yeah, add all the sides.
Add them all up, that's right. So it's going to be x plus 182 over x plus 182 over x. I'm going to go ahead and simplify that a little bit. 2x plus, what's 182 and 182? 370.
364.
Yeah, thank you. And I went ahead and used function notation and said P of x for perimeter because it says express the perimeter as a function of x. So the perimeter in terms of x is 2 x's plus 364 over x. Would everybody agree with that? All right, so that's A, that's part A. Now part B says, find the dimensions of the rectangle that has the least perimeter, and then what is the least perimeter? So basically, guys, don't we want to find the minimum value of this? Isn't that what we're doing? So let's get our calculators out. And let's graph this thing right here. So we're just going to type in 2x plus 364 divided by x. And obviously we got to see something. I did not use, I just used a standard window That's the way my calculator was set up. I hit graph, I don't even see anything, so I know I need to do some changing here. Any thoughts on what a window might look like?
For the X-Men, maybe a negative 400 and X max positive 400.
Okay, let's talk about that for a second. For X min, negative 400. Now, what does X stand for in this problem? What does the X represent?
It's just the I guess the width.
Uh-huh.
The width.
So does negative 400 seem like a good idea?
No.
No.
It doesn't.
What seems like a better idea, maybe?
Change the Y min and max instead
Well,
of the X.
Yeah, we're going to change them all, but what's the smallest X could be? Can it be negative, you guys?
0 to 2.
Yeah, it
Or is
can't be negative. So I'm just going to put 0 in for X min. Please tell me that makes sense to you. You cannot have a negative width over here. So I don't know what it is, but I know it's going to be positive, right? Now, what did you say for the max? I have no idea what the max is. What did you say?
I didn't say anything for the max,
okay.
but I think I guess maybe 5 or 6 seems fine. I don't know if we need to go over that.
Well, that's up to you. I think I'm going to put in 15. Y min, now remember, Y represents the perimeter. Y is the perimeter. So I'm going to use 0 for that minimum also. And I'm going to go with 100 for Y max and see what happens. All right, I actually, as I was messing around with it, I made a slight adjustment. For my X's, I used 0 to 25. And for my Y's, I ended up with using 0 to 100. And I got a picture which allows me to see a minimum. And that's all I care about. I really don't care about the picture itself. I just need to be able to see a minimum. And that window gives me a minimum. So now I'll do second calc, minimum, and I'll try to figure out what that minimum is. Now on test or quiz day, I'm not going to be standing here telling you how to set your window, so you're going to have to play with it a little bit, keeping in mind always what X and Y stand for and what's reasonable for them. The nice thing about your calculator is you can make as many adjustments as you want. It takes about a millisecond to change those numbers, so play with it as much as you need to. Did anybody get the same minimum that I got? Can I see a thumbs up from somebody? Grace, you nodding at me? Are you outside?
Yeah.
Is it
I'm
warmer?
in Florida.
Oh, okay. All right, thank you, Grace. Thank you. If it weren't illegal, I'd make you turn your camera off, but that's okay. I'll stand here and be jealous. All right, so now I'm going to answer the question. I'm going to answer the question. The first question was, find the dimensions of the rectangle. So the dimensions of the rectangle are here, 13.49, and then 182 divided by 13.49. Oh my goodness gracious. 13.49 feet by 13.49 feet. Those are the dimensions of the rectangle. In other words, if I want this thing to have the smallest perimeter possible, I make a square. And then the last part of the question says, what is the least perimeter? Right here. This is the least perimeter. That was your y value. Your y value was the perimeter. So your least perimeter is 53.96 feet. Okay? All right, there's one more section in this chapter, and it has to do with inequalities. So let's see what's happening here. So think about all the kinds of problems that we have done in the last few days. And now we're going to do them all, but they're going to have inequalities. Less thans and greater thans instead of equal signs. Okay, let's start with this first thing, though. We got this big polynomial. That's a big polynomial function. And we want to know, in intervals, where is it positive, where is it negative, and where is it 0? All right, let's not make this too hard, all right? Let's think about a number line. And I think you could tell me right off the bat where this thing will equal 0. What are the zeros of that polynomial? What would make this thing 0? What?
It's like the x values, it's like -3.
Yeah, so one of them's -3. That's going to give me a 0, right? I'll just put a x there. -3. Do I have any others? Is that the only one?
2. Or I don't know if that's correct.
Well, plug 2 in. Does it give you 0?
No.
No. So it's not correct. What's another number I could plug in and get 0?
4.
Yeah. So if you let x be -3 or 4, you end up getting 0 as the value of that polynomial. I'm not sure why I have. Hey, Vincent, this is B period, honey.
Oh, sorry.
That's okay, I'll see you in a little bit. All right, if I plug in -3 or 4, I get 0 as the value of the polynomial. Now, don't be confused by this one. Is there anything you could plug in here and make this 0? Is this ever going to equal 0? No, not in real number land. If you were allowed to use imaginaries, you could make that 0. But in real number land, squaring and adding 1 does not give you 0, ever. So no zeros are coming out of that. We get -3 out of this one and 4 out of that one. You guys have done this a million times. It's where you put the dots on the number line when you graph this kind of thing. Now, Notice that those zeros have split my number line into 3 pieces. What happens if I choose numbers less than -3? Like, oh, let's try -4. What would happen to this parentheses if I put in -4?
Turn to -1.
Yep, it'd be negative. And you feel free to use the actual number. I am interested in positive and negative, so I really don't care about the value. I just care that it's negative. But yes, it would be -1. What happens if I put -4 in here?
Positive.
Yep. And what happens if I put -4 in here? Now be careful, you are squaring that one. So when I put in -4 here, this would be,
It's
Positive.
yeah. So if I let x be any number out here, I chose -4, you could use -5, -10, -77, I don't care. Any number out here, this parentheses would be negative, this one's positive, and this one's positive. When you multiply them all together then, this area would be negative, right? Because negative times positive is negative. So one interval where this thing is negative is the interval from -infinity to -3. Any number in this area is going to give you a negative result. All right, let's move over here and try the next space on the number line. We started by finding our zeros because that's what splits the number line up. And now we're just looking at each section of the number line. So I think a number in here to try would be 0. That's nice and easy. If I put 0 in, what happens to the first parentheses?
positive.
Yep, positive. How about the second one?
Positive.
And the third one?
Positive.
Hey, they're all positive. So in this region of the number line, any number that I plug in is going to give me positive times positive times positive. That's positive. So the interval from -3 to 4 will produce positive values for that function. Well, what happens if I'm bigger than 4? Like 5. What happens to my parentheses if I put in 5?
It's a positive.
They're all positive, aren't they? If I put in 5. So I am positive not only from -3 to 4, but also from 4 to infinity. Okay? Now, once you take your calculators back out, I want you to set up a standard window. I know we messed it up in the last problem, but just set up a standard window. And then type in this function right here. Just type it in with the parentheses. Parentheses x plus 3, x squared plus 1, x minus 4. Don't forget to square that one. Now, in order for you maybe to get a little bit better sense of what's going on, would you change your y max to 100? Now, when you graph this thing, you get something that looks like this. Now, we spent a lot of time graphing these polynomials, so I know you kind of understand what's going on. It's an x to the fifth, so it's starting down and ending up. But what I want you to look at now is the entire picture is above the x-axis except for this little part right here. Everything else is above the x-axis. Would you agree with me? That means it's all positive. That means this thing is positive everywhere except here. And isn't that what your answers bore out over here? You said anything up to -3 is going to be negative. But after -3, everything is going to be positive except where it actually equals 0. These are the two places it equals 0. Here's where it's negative, and all the rest of it is positive. All right. Let's do a couple of these now and actually solve some problems, see if we can come up with the answers. We're not going to be using our calculators for these, although our calculators would do them for us. We're going to be doing them by hand with a number line. So here we go. We're going to solve this thing. So I am looking for places where this polynomial is less than or equal to 0. Anybody have an idea where how I might start?
Look for the zeros first.
Yep, and that's easy. I can look at the problem and tell you where the zeros are. Where are the zeros? There are 3 of them. Where are they?
-7.
Yep, -7, -4, and +6, right? Those are my zeros. I'm not graphing this. I'm using the number line to help me solve it. Those dots should actually be filled in. Would you agree, since it's an or equal to problem? And now I'm going to do exactly what I did a moment ago. I'm going to start picking numbers, and I'm going to try to figure out if, when I put that particular number in, whatever number I pick, does it end up being a positive or a negative result? My answers will be the ones that are negative. Okay? So, doesn't matter where we start, but let's be organized. We'll just start down here. So I'm going to put in a number like -8 or -9. It doesn't matter, guys. Any number over here. What does it do to these parentheses? Well, -8 would make the first parentheses negative. -8 would make the second parentheses negative. And everything will make the third parentheses positive. Why is that third parentheses always going to be positive?
Because when you square negative,
Exactly.
it will be positive.
Exactly. This one's squared, so it's going to be positive no matter what. That third one's going to be positive no matter what. Okay, but when I put in my -8, so I ended up with a negative, and a positive. So when I multiply all that together, don't I get positive? Is that what I wanted? Guys, is positive less than 0?
No.
No. So I don't want that. That's not part of my answer. All right, let's try it in here. Let's see what happens in here. Like maybe -5. -5 would make a positive, and a negative, and of course a positive. So if I put in a negative 5, positive, negative, positive, those multiplied together make a negative. Is that what I want? Yep.
Yeah.
So that area, that region of the number line is going to be part of my answer. All right, let's try in here. -4 to 6. How about 0? Let us use 0. Any number in there is fine. 0 would give me a positive, and a positive, and of course a positive. So does that area work for me?
No.
Nope. Don't shade it in. Doesn't work. All right, how about something out here like 7? 7, isn't that also all positive? Positive, positive, positive?
Yeah.
So that doesn't work either. So the only section of the number line that has answers is the little interval from -7 to -4. Because that's the only part of the number line that has numbers when I plug them in that give me a negative product, less than 0. Oh, wait a second, there is one more answer. Can't forget about that. Didn't I color that dot in? So even though I'm not shading anywhere around it, that 6 is included as part of the answer, because it would give me equals 0 if I plugged it in. All right. Good work. Let's see what's next. Uh-oh. What do you think you're going to do here?
Factor?
Yeah. And luckily,
Divide.
okay, so we have a couple different strategies. Now that we practiced all that stuff earlier in the chapter, you know about PRRs and synthetic division. However, take a close look at the problem. Do we need to go through all that, or do you think we can group it?
I think it's groupable.
I think it's groupable. But if you don't notice that, or you don't want to do that, you certainly don't have to. You can always do your PRRs and guess. Okay? George, why do I not see your face? I have to count you absent. Thank you. Make sure I see your face, not the wall or the ceiling or whatever that is I'm looking at. All right, so I'm going to group this thing. I'll take out an x squared. What can I take out of the last two?
Negative?
Just
one.
a -1. Yep, that's all that'll come out, just a -1. So luckily, when I took out a -1, it left me the same parentheses. So now I can factor that. And there we go. So I ended up with these 3 factors. What about the rest of you? Does that look okay to everybody? Someone nod? Thank you. So now my job is to figure out not the roots. We already did that back earlier in the chapter. Now we want to know where this thing is positive. So here's my number line. There will be 3 open dots on the number line. Does that make sense to you? If it doesn't, you need to speak up. And those open dots will be at -1, +1, and 4. please make sure when you put them on the number line that you're putting them on in the right order. This is a number line. So you can't just willy-nilly put the numbers on. All right, now what do I do? Declan, what do I do now? I got my dots on there. What do I do?
You pick a number, like, on one side of one of the numbers on the number line and see if it works or if it's positive or negative.
Exactly. And in this case, working, when you say it works, Declan, in this case, I need it to be positive, right? Greater than 0. So I am looking for positive products. Not that each of these individually is positive, but that they're times together to be positive. So let's try -2. -2 would give me a negative, and a negative. If I put in a -2, I get -6, -1, -3. You may use the numbers if that's easier for you, or just the signs. Whatever is most conducive to you getting the picture here. Anyhow, negative does not give me positive. So this is not part of the answer. I wonder if 0 works. Putting in 0 would give me negative, positive, negative. When you multiply negative, positive, negative, you get positive, which is great. That means this is part of my answer. Now, when I stick in 2, I would get negative, positive, positive. If I put in 2, and that does not multiply to give me a positive, that's a negative. And then if I put in 5, I get positive, 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 so that'll work. So my answer is everything between -1 and 1, that's shaded in there, or everything from 4 to infinity. We actually looked at these problems earlier in the year. I hope it sort of looks familiar to you. Does anybody remember that alternating thing that we talked about? Why did this one alternate? And when I mean by alternate, I mean it didn't work, it did, it didn't, it did. Why did that work on this problem, but it didn't work on that first problem we did? Who remembers kind of the rule about using that little alternating trick?
Doesn't it have something to do with like upper bounds?
No, I don't think so. It has to do with having factors that are abnormal. And in this case, these are all considered, they're just straight factors. X minus 4, X plus 1, X minus 1. There's no duplicates. There's nothing special about any of the factors. This problem has a squared factor in it, and that messes everything up. When you have anything other than just straight factors, the alternating thing gets thrown out the window. As long as your factors are just boom, 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 nothing special about them, just regular old factors. Once I figured out this wasn't shaded, then I could pretty much predict what was going to happen after that. But if you're at all confused by that, then you're not going to use that, and you are going to do exactly what we did, and that is just test a number in every region. All right, there's our answer. We're ready to go. Let's look at the next one. right, what do you think about this one now? What's the first thing we're going to do? This is an inequality. So eventually I want to get it onto a number line so that I can start shading in the areas that need shading.
You have to use the PRRs.
Yeah, I don't see any way to group this thing. So just as a matter of review, I'm going to list my PRRs over here to the side. So they're going to be factors of 24. So 24, 12, 8, 6, 4, 3, 2, 1. I think I got them all. Over factors of 2. So while fractions are not going to be my first guesses, they could be yours. It doesn't matter, I gotta guess something. In the possible guesses, you do have things like 3 halves and 1 half as possible guesses. I don't know, what do you think?
4.
4? Let's give it a shot. We haven't done any of this in a while. Feels kind of good to get back to, oh, wow. Awesome. Good job. Good job. Now, what does that mean? That means that one of my factors is what?
X minus 4.
Yep. So there's going to be 3 of them all together, 3 factors, x cubed, and I now know that one of them is x minus 4. Okay, how am I going to find the other ones?
You gotta factor it or use a quadratic equation.
On what's left here, which is 2x squared plus x minus 6. My guess is this factors foiling that out for my, yep, there it is. So my other 2 factors are 2x minus 3 and x plus 2. As Jacob said, however, if you don't want or can't factor that, then you can use the quadratic formula. Because at this point, it's a quadratic. Now, we did this before. We were pretty much done. This tells me that my zeros are 4, -2, and 3 halves. But I'm not done, because this is an inequality. So I got to find out where this thing is positive, greater than 0. So, George, what do I do?
Go on the left side of -2 and find your signs.
All right, so I'll pick a number out there like -3.
Yeah.
So that would give me a negative. If I put in a -3, it would actually give me a -7. Use the number if it's easier for you, or just the sign. It would be negative. Putting in a -3 here would also be negative. And putting in a negative here would also be negative. So putting in a -3 makes all of my factors negative. Multiplying them all together, then, I would get a negative. Obviously, negative times negative times negative is negative. That is not what I wanted. Okay? So at this point, kids, if you are comfortable, with the shortcut, you can use it because these are just regular factors. There's nothing squared, there's nothing weird going on, they're just straight factors. If this section doesn't work, then this section will, this one won't, and this one will. If you are not comfortable with that, then you're going to pick a number in here, like maybe 0, and you're going to put it in, and notice that it gives you a positive result. And then you'll pick a number in here like 2 or 3, and then you'll pick a number out here like 5 or 6. And you will discover, just like I did, that the answer to the problem is that. Everything between -2 and 3/2, or everything from 4 on. All right, anybody have a question about that? All right, number 5 looks like kind of a similar problem, but it says use your calculator. So let's talk about how we might efficiently use our calculator to do this problem. We have a couple of different strategies we can use. But let's talk about this for a second. Let's go back to a standard window. And let's graph the left side as one equation and the right side as the other equation. So x to the third minus 6x squared, that's going to be one equation. And then 2 minus 8x is the other one. Ooh, not a good picture. Not a good picture. Nope. So I could spend some time playing around with this to get a better picture. But you know what? I'm going to pick a different strategy because there's these things, the picture's just not very good, and I don't want to waste a bunch of time trying to make it decent. So I'm going to do this. Just set the whole shebang on one side, so add the 8x and subtract 2, and graph that and see what that looks like. Let's see if that helps clear things up for me. Oh yeah, that helps a lot. So I got something that looks like this. Did you? Now, make sure you understand where your answer is going to come from. Your answer is going to come where your curve is less than or equal to 0. Now, I think there are 3 places where it equals 0. Would you agree with me? And you know how to find those places. Those are the zeros. You're going to second calc 0, and you're going to find those points. And the last time we did this, that was our answer. X equals this, X equals this, X equals this. But now we want to know not only where it equals 0, but where it's less than 0. So your answer is actually going to be from negative infinity to this number, or from this number to this number. Those are going to be your intervals where your equation is less than 0. Does that make sense to everybody?
Yeah.
Let's find those points then. We're going to find them just like we did before. Second calc. I know finding all these roots is a little tedious, but just be so happy that you have a calculator to do it. I had to do these problems when I was your age, but I had to do them without a calculator. It's a whole different ball game without a calculator. Is our period over already? Oh my gosh, you guys, our period's over. Let's go ahead and wrap this up. Did you get 0.32, 1.46, and 4.21?
Yeah.
Okay, so how do we write our answer? Remember, we're looking for where the curve is negative. So that's going to be everything up to 3.2. So negative infinity to 0.32. Or everything between 1.46 and 4.21. And oops, those are closed dots. So I need a bracket there, a bracket here, and a bracket here. And that is my answer because of the or equal to on there. Now, we used the calculator on that, not because it was any different than any of the others, but because this problem doesn't factor. So because it doesn't factor, we need a calculator to help us find the roots. Okay? All right, thank you guys. Have a good Thanksgiving. Stay safe and healthy. I'll see you on Monday.
Thank you.
Thank you.
Uh-huh.
Thank you.
Bye-bye.